quickly the answers from the warm-up there. Our x-intercepts are at 1, 0, and 5, 0. So just be really careful when you write those as coordinate points to make sure that the x value comes first and the y value comes second. The orientation is positive because it's facing upwards. The vertex is down here at 3, -4, and that vertex is going to be a minimum because it's at the bottom of the parabola and everything else is moving upwards. So if we put all of that information together into our equation, then our correct equation is going to be the last one there, h of x. So let's just recap that just a little bit. So remember, when we write our equation for vertex form, we're going to take the x value of the vertex and flip the sign. So we're looking for x minus 3 inside the parentheses, and then that -4, the y value, stays the same. So that's going to say -4 at the end of the equation outside of the parentheses. And then since it is a positive orientation, we want to choose h of x versus g of x, because g of x has that negative sign there at the very front of the equation, which would indicate a negative orientation. But we know we have a positive orientation based on our graph. And Liliana, that's no problem. Welcome. Thank you for joining us today. Do you need me to send you the link, or can you see it there in the chat? Okay, perfect. Then just go ahead and hop in our activity and we're going to keep on going. So does anybody have any questions about that vertex form? Okay, so then what we're going to do today is we're going to look at another form of our quadratic functions. There are 3 total forms. So we've learned about vertex form. We're going to learn about another one this week, and then we'll learn about our last one next week. And as we're going along, we're going to continue to practice all of our forms. Okay, so while we're learning about this form today, we will also not be forgetting about our vertex and our vertex form. So take a look at these 2 graphs and their equations. So the graph that matches f of x is right below f of x. The graph that matches g of x is right below g of x. Tell me what you notice and what you wonder about those graphs. So as you're looking at them, think about your key features. What do you see on the graphs? How might that show up in the equations? That kind of stuff. I'll give you a few moments to get at least one notice and at least one wonder. Ooh, really good. So I'm going to share a couple of the thoughts that you guys are sending in. So I noticed that both graphs have positive orientation. So great. That's good to notice right off the bat there. I noticed that the x in the equation connects to the points on the graph. I wonder what that means. Somebody said they look the same, just mirrored. So that's a really good observation. So think about, before we move on here, think about your key features. So take a look at the numbers in the equations and think about what you're noticing in your key features on your graph. How are those numbers in the equations related to a key feature on the graph? All right, so, oh, hang on. Keep going. You can keep typing. Okay, so if we look at those two graphs and equations, we can see that the first equation, f of x, has two minus signs inside of the parentheses. And we can see that g of x has two plus signs inside of the parentheses. So those of you that were noticing that they look like mirror images of each other, that has a lot to do with it because this one has just minus signs and this one has only plus signs. Now, take a look for, oops, sorry, didn't mean to move you. Take a look for just a second at each of those equations. Think about the fact that f of x has two minus signs. What side of the graph do we notice f of x being located on? And then g of x has two plus signs. And what do you notice about the side of the graph that g of x is located on? Anybody see anything there? And feel free to unmute or you can type it in your response box, either way. All right, so if we dig into that with those signs, and we look at our key features, notice if you haven't already that f of x, like I said, has two minus signs and it has two positive x-intercepts, one at positive 1, 0 and one at positive 5, 0. And then the second one there is x plus 1, x plus 5, and that has two x-intercepts, both that are negative, at negative 1, 0 and at negative 5, 0. So just like with our vertex form, the number inside of the parentheses is the opposite of where we actually cross the x-axis on the graph. Okay, now this is not written in vertex form. These are both written in a different form. The way that we know that is because vertex form has one set of parentheses with the squared and then the number at the very end being added or subtracted, whereas this form has two sets of parentheses and no number at the very end being added or subtracted. So it's not going to tell us about where the vertex is because it's not written in vertex form. So what we want to do is think about how this connects to other key features on our parabola. So keep that in mind, which you just saw here on this slide, and let's look at this graph. Based on this graph, which equation is correct? So the key here is to remember that whatever we see on the graph is the opposite sign in the equation. Just like with our vertex, when we wanted to shift to the right, the equation actually had a minus. So same thing is true here. So if we look at the graph, we've got an x-intercept at negative 1 and an x-intercept at positive 3. And I just realized I wrote those backwards. Those notations are backwards. But it should say negative 1, 0 and 3, 0. So we're going to take those x-intercepts and flip the sign to get the correct equation. So since I crossed the x-axis at negative 1, that's going to say x plus 1 inside of the parentheses. And since I crossed the graph at positive 3, that's going to say x minus 3 inside of the parentheses. Okay, so this equation is actually called factored form of a quadratic function. Okay, So anytime you see the two sets of parentheses like this, that's going to be called factored form. So the a value, notice it's still at the beginning of our equation, right after the equal sign. That's still going to describe the orientation for us. So if this number is positive, the orientation of the graph will be positive. And if that number is negative, then the orientation of the graph will be negative. So what's new are these two sets of parentheses. So notice it says x minus r sub 1 and x minus r sub 2. The R represents the x-intercept. The reason that we're using those little subscripts is because they represent the same type of information, but they're not the same number. Okay? So they're two different x-intercepts, so we can't just call it R and R. All right? But don't get hung up too much on that subscript because they're just going to represent numbers anyway of where we're crossing the x-axis. So each of these sets of parentheses is called a factor. Okay, that's why we call it factored form. So anytime you see your equation like this, it's going to tell us what the orientation is and where the x-intercepts are located. And remember that the sign in the factor is the opposite of where it's going to cross the x-axis. So let's look at this example. What are the x-intercepts of the quadratic function given below? All right, great job. The correct answer is B. So we're going to take those signs and flip them. So we're actually going to have x-intercepts at positive 11 and negative 5. Are there any questions right now about what we're doing here so far? All right, let's go ahead and try this one then. So using that equation, f of x, tell me what the orientation is and where the x-intercepts are. All right. Okay, so remember that the orientation comes from the very beginning of the equation, right after the equal sign. So since that's a negative there after the equal sign and before the parentheses, that is going to be a negative orientation. And then the x-intercepts are at +3 and -1. All right, so take a look at this graph. Which equation matches that graph? All right, great job. It's going to be equation K because we're going to flip the signs. We've got -5 and +2 on our graph as our x-intercepts. So those are going to flip to x-2 and x+5 when we write the factors. Go ahead and try this one. All right, so remember those signs flip from the equation to where we would actually be located on the graph. So we're going to be at +2 and +4 on the x-axis, and the orientation there is negative. Draw what that should look like. So plot your two intercepts and then sketch a parabola with a negative orientation that goes through those two intercepts. And don't worry, I'm not judging your drawing skills because mine aren't the best either. Just want to make sure you've got the right orientation in mind and you have the right you're plotting the correct points. So as long as I can see those two things, you're good. Liliana, that works, sweetie. Good, Esmeralda, that looks good. And good job, Anna. Very nice job. All right, do you guys have any questions so far? All right, go ahead and try this one. So same thing. What's the orientation? What are your x-intercepts? All right, looking good. So just knowing that we're flipping those signs and our orientation is positive. So now go ahead and sketch a graph of what that should look like. That's okay, Amari. Just jump right in with us and we'll catch you back up. All right. So just going back through that, and Amari, what we're working with here is now called factored form. So when we have those two sets of parentheses, instead of the vertex form that had the one set with the squared behind it, now this tells us the orientation and where the x-intercepts are located when it looks like this. So the orientation still comes from the very front of the equation. So since there's nothing there, that's going to be a positive orientation there. And then we still do the opposite sign just like we do with vertex form when it's inside of the factor or inside of the parentheses. So since this first factor said x plus 1, what that told us is we were going to have an x-intercept on our graph at -1. And then since the second factor says x minus 6, that tells us that we're going to have an x-intercept at +6. Okay, so if you've got any questions, let me know. This recording will post later, so you can go back and watch the full thing. And there will be a set of notes posted as well with your independent practice. So you have all of those resources that you can use. And then, of course, if you still have questions, you can reach out to me. All right, so looking at that graph, which equation would correctly model that graph? So remember, check your two things that we've been working with. Check your orientation, check your x-intercepts. And remember, from wherever we cross the x-axis on the graph, it's going to be the opposite sign in our factor. All right, so it looks like we got some disagreement here. So the correct answer here is actually going to be the first equation, f of x. So the reason that it's f of x is because it's got a positive orientation on the graph. So that automatically knocks out the second equation, h of x. And then now we just have to remember that we flip the sign from the graph to the equation. So our first x-intercept is at +1 there on the right-hand side. So that's going to flip when we write the equation to x minus 1 in the factor. And then at -2, 0, that's going to flip to x plus 2 when we write the equation. Are there any questions about that one? All right. So now take a look at this graph and let's see if you can't come up with the equation that models this graph.
Miss,
Yeah, go ahead.
the first two letters can be fx, right?
Yeah, that's fine. You can use whatever you want to name the function.
Oh, okay.
All right, so it's a positive orientation, so we're going to not have a negative sign there at the beginning, which all of you did that well. And then just remember that since we have two positive x-intercepts, then we're going to have a negative sign in both of our factors, or a minus sign in both of our factors, okay? So just keep in mind that opposite rule is still in effect. If we want to indicate that we have shifted the parabola right on the x-axis, it needs to have a minus sign in the factor. If we have shifted the parabola left on the x-axis, then it needs to have a plus in the factor. Okay? All right, so based on this graph, what is the missing factor in this equation? Give you just about 30 more seconds to get that one answered. Sorry, my dog's going to start barking at Lord knows what. All right, so you guys are right. That is, in fact, going to be x plus 4 because our other intercept is at negative 4. All right, so remember how at the beginning of class I talked about how even though we are learning about a new form, our vertex form is still not going to go away. So take a look at this graph and circle all of the equations that are correct. Can you all see that slide? I just want to make sure that I'm at the right place and I don't need to refresh or something. Okay, thank you. So you're going to circle all of the equations that are correct for that function. Or excuse me, for that
Miss,
graph. Yeah, go ahead.
yeah, the first, it is a 2 or a 1 because I can't see it.
Oh, for the x-intercept, it's a 1.
It's a 1?
Yes. Give you about 30 more seconds on that one. All right, so the correct answers there are going to be equation 1 and equation 3. So your first two equations were in vertex form. So we wanted to look at where is the vertex and then choose the correct equation. So that is going to be equation 1 because of the negative orientation. So remember, the vertex is up here. It's a maximum up here at negative 1, 8. So we're going to flip the sign to make that x plus 1. And then the 8 stays the same sign. And then we put that negative at the very beginning to show the negative orientation. For the factored form, both of them start with a negative orientation. So you're paying attention to the signs inside of the factors. So my x-intercepts are at positive 3 and negative 1. So those are each going to flip. So my x-intercepts are at negative 3, 0 and positive 1, 0. Sorry. So my factors are going to flip to become x plus 3 and x minus 1. Are there any questions right now about the factored form equation? All right, so here is your exit slip for today then. You're going to circle the graph that matches the equation there that's provided. So one of those 4 graphs there to the right. And then just give me a rating from 0 to 4 of how much you feel like you understand the factored form. If you haven't done your quiz from week 14, please make sure you get that done. And then week 15's independent practice on factored form has posted. And have a great Cinco de Mayo. Once you are done with the exit slip, you are free to go.